Hey, good afternoon from sunny Cambridge. So the last week we looked at how to generate terrain objects. We got the basic shapes down. This week, let's go deeper and find out how to improve them. Here's a sneak peek of how it would look like compared to what it was. Hope you enjoy it. So last time we looked at a terrain object which has a center, radius, and a paint object. So it can be colored. We initialize the paint object here. And then there's a generate method. And then there's a draw method, which just draws a circle. I will quickly refresh your memory about the generate function. So it takes in the level, a center, a radius, and a list of terrain objects, and a palette. This is the difference between the previous method and this new method. This is how we're going to color it. It will have levels as many as the number of colors that are in the palette. Here we clamp the index so that we can get the correct color, and then create a terrain object, put that into or insert that into the fractal list of terrain objects, and then create the secondary objects. So the first or the main object is this circle here. Secondary objects are the smaller circles on the perimeter of that circle, or the circumference of that circle. The way we do that is to generate a random angle between 0 and 360, assign this to a polar coordinate object, and then convert that into Cartesian coordinates at the center, and then call the generate function again recursively. So this is the exit condition, so that eventually it will exit. This is very important, otherwise it will just infinitely loop and crash the application. Okay, so that's the basic or the base class of all the terrain objects we're gonna create. Now let's take a look at the forest class, which is derived from the terrain object. Here's where we keep a list of the terrain objects, because if it is a forest, then you have number of trees, so that's what this represents. And then the draw method, which will iterate through the objects and then call the draw function, which is this here. Okay, so basic algorithm is very simple. It's a matter of coloring it properly. So in the state object, so this is where we call all these functions, or this is where we generate the whole thing. Over here we have, just to show you that I'm just creating only one forest, because it's a collection of three objects, and we create a random radius and also give it a random position so that it will appear randomly on the screen, and then we create a forest object, right, with those parameters. So if you have like multiples of it, then we'll have multiples of multiple forests. So that's the whole idea. Let's take a look at the painting. This is what makes the difference. So if I change that to fill, then refresh, you see something like this. This is because we have a color set over here, water, rock, and 3 colors. So we have 4 colors, each of which is a shade of green, dark to light, and then in the terrain object we assign the color of that terrain object relative to that level. So since we are drawing the main object and then drawing parameter objects which are lighter, and then more parameter objects recursively even lighter than that, then we have this kind of a pattern. It's very easy to do. It's just a matter of experimenting with the colors. And if we generate more of these, let's say 10 to 15 of them, then it will look like this. And every time you refresh, you will have a different set of foliage. Alright, so let's take a look at how to draw lake objects. Right now we are in the state container. That's where we start all the drawing. So I set to one object so we can see what's going on, and it creates just one lake object. Just as before, we are using terrain object, which has the center, radius, and paint. So let's take a look at the generate method. This is a little bit different than the previous one we used. The bits that are different is the way we select the color from the palette. So in the previous, when we drew trees, we had something like this. We just select a color based on the level it is drawing. So if we have 2 colors, as you can see, it will only draw 2 levels. If we increase the number of colors in the palette, then we would have more levels. Let's take a look at that. So in the style, I only have 2 colors enabled. So let's enable one more color and take a look. Right, so it will draw more complex shape. And again, more complex shapes, and again even more complex. But the thing is that this doesn't really look like a lake. It looks like a blue cabbage. Even if we so this is only stroke, but if you fill it, you will see the same thing. So this is the problem that we are trying to solve. In the terrain lake object, if we go with a different way of coloring, for example here, what I do is I select the color depending on the distance from the center to the circle that we are drawing. So if we do that, then we would get some other interesting effect like this, which is kind of like what we would expect in a lake. So in order to do that, we need to find the max distance. This is done by adding up a geometric series. The reason why this is a geometric series is because when we draw a circle, we draw the radius, and then the next level it is half that radius, and the next level half that radius, and so on. So if you think about that, every time at every level it becomes half the distance of the previous circle. So when you add up, if they all line up in a straight line, then it will get the maximum distance, and if you add up those distances, that's the maximum distance that we can get. So there is a formula that can be used for the maximum distance, and it looks like that. That's what we have here. So once again, let's take a look at why this is a geometric series. A here is the radius and R is the proportion. So when we look at our recursive function, we send half of radius into it every time. So it becomes half, 1/4, 1/8, 1/16, and so on. The R represents that. So that's why it is a geometric series, and we compute the maximum distance like that. An interesting thing to note is the number of object counts. Every time you refresh, you get a different object count, but this is something that we have to deal with, because if there are a large number of objects, then it takes longer to draw it. This happens because we draw circles inside other circles. Because if we select the angle at random, it is possible that the subsequent circles will be drawn inside the previous circle. So if we do some filtering, we can possibly reduce the number of circles that we would be drawing. So that's the purpose of this filter out overlapping objects. And if we enable that, you can see how many objects are eliminated. And after the elimination, we get quite a low number. So from 22,000 something to 500 or something like that. Also, the effect becomes a little bit different and a little bit more organic. So that's something that you can experiment and find out for yourself. Let's make more objects like that and see how it looks. Okay, so there's a possibility that they would overlap, and it gives a different effect, but it's also more natural, I think. These are the things that you can experiment and see how you would want to place them in your terrain. We're going to draw some rocks now. So we're back in the main place that we draw all these things, and I'm drawing one mountain object. I don't know why it is called mountain, but okay, it's a rock. Let's take a look at the terrain mountain class, or mountain object class. It has a special class, or support class that we use. This is a little bit different than the previous ones because this is not a fractal. It is layered geometric shape on top of each other. So we use a special class called contour to have these we have a palette for the rock, and it looks like that. But let's remove some of these and then see how it looks like. So now you can see each layer, how it is drawn. So it's sort of like a irregular polygon. This is where the contour class comes in handy. So it has two methods, add point and draw class. We use a path, and the add point adds a point in that path. So the way we do that is that each of these points will sit on a kind of like a circle, but we change the distance and the angle. We use canvas draw path to draw the whole thing. mountain object looks like that. Even though it has a list of terrain objects, we don't really use that. So we have a list of contours and something called the max height. We will get to that later on. Generate is a little bit different, even though it is similar. It has the level that we recurse on, and then we have something called the perimeter point count. This is similar to the angles that we created. In fact, we are creating some angles on that. So we come up with a number of points on the circle, on the circumference, and then create a bunch of angles. It's similar to what we did here for the secondary, the alpha, and creating polar, but we don't use it that way. We just use an angle first and then we sort the angle. The sorting is important because otherwise you would not get a closed shape like that. It would be really spiky, some random thing like that if you don't sort. So sorting is important. So this is how we do it. We create a contour object and then keep adding points onto that. The difference here is that even though the points are on the circumference of a circle, we want to make it a little bit more irregular. That's why we have this radius delta, which is a random number. So we vary the radius by a little bit. That would give this irregular kind of a rock. Otherwise, you would have very roundy or conic like objects. We don't want that. We want this randomness to be there. So the polar object converts that to the polar coordinates, and then we convert back to the Cartesian, shift it to the center, and add point. So there's a bit of a back and forth there, but makes it easier. Now we add the contours object into the list, and before we get to the next level, we want to vary the center of the circle a little bit. This would give this added randomness to the rock object. We also reduced the radius a little bit. That's why we need to calculate this max radius delta. So since we were varying the radius at each of the point on the polygon, we want to calculate how the largest delta, so that it would be smaller than that in the next level. That's the whole idea. So when the rock goes up, its radius becomes smaller. The next element of randomness we achieve by varying the height of the rock, because if they are the same height, then they look more similar. So we want to vary the height by the number of colors. That's what we are doing over there. Let's increase the number of palette colors and see how it looks. So as you can see, when we add more colors, you will see that the levels with different shades of brown appears. And also it is random because the height of that rock is random. Add more colors. Right. Now you see some contours on that, so that gives a nice effect. And if we add all the colors, then we can see the whole effect. Okay, let's take a look at how this would look like with more objects. As you can see, there's a good variation of the shapes of the rock, how high they are, their colors, their positioning, and so on. So that's what we want. Let's put all these things together and see what the terrain looks like. Fantastic, don't you think? So depending on your application, you can experiment with various elements of this type of terrain generation and use what makes sense for you. So that's it for this week. Go ahead and create something cool, experiment with these ideas, and I would love to see what you create. So leave a comment with a link to your experiments or videos or GIFs or games or whatever. I would really love to see it. Alright, thanks again for watching. Until next time.